This is Techzine Talks on Tour, the podcast about enterprise technology that brings you IT insights and analyses from events all around the globe. We cover everything, everywhere. Visit techzine.eu for more information, and don't forget to subscribe to this podcast.
We are here at Dreamforce, the conference of Salesforce. We're here with Adam Evans. He's SVP Product, Salesforce AI Platform. It's a big title, Adam.
It's a big company. Yeah, exactly. So yeah, what that means is I'm in charge of product on our platform side. So that's reusing things like Agentforce, co-pilots, prompt builder, basically anything that's Gen AI inside of Salesforce. That's kind of falls into my realm from a product perspective. Okay,
so you kind of developed Agentforce with your team then?
Yeah, it's a large team. There's a lot of people behind Agentforce, and my background is I've come to Salesforce twice through acquisition, and focusing on AI for sales automation at first, and then the second acquisition last year was more about applying AI into service, meaning kind of self-service. So you see aspects of both of those in both product and team and more.
Throwing all your business data at AI and prompting it doesn't work. That's basically what the hyperscalers are doing. The adoption rates are pretty slow, and you guys think you have solved it with Agentforce. Can you explain a bit what it is?
Yeah, so I think that, the solution, there's always more you can do. The nature of large language models, stochastic systems are probabilistic, so it's a question of can you get it right more and more accurate, better kind of each time. So it's never maybe fully solved problem, it's always the pursuit of it, right, just to be clear. And what we're saying is, we think about, AI is only good as kind of the data that you have in it, if you think of it that way. A lot of this boils down to, with like large language models, thinking about what are all your systems about getting the right information into the prompt. And I use information as opposed to data because it's natural text at the end of the day for at least large language models. And knowing how to pull out the right data from Data Cloud in kind of the right context and the right moment, and have that go into LLM, and do that kind of in concert with other information. So like, for example, if an agent is in a conversational setting, how much of the conversation history with the user that it's talking to or having a conversation with do you want to have in there? If it's a really, really long running conversation, do you want the whole thing? Do you want a little bit? What are the important aspects of that? What about, for example, if the conversation was moving into questions about policies or product information, things that might be inside of kind of your knowledge base for help, or a deeper kind of unstructured data set. This is being able to search through that, and we say semantic search or vector search, and kind of your audience is quite technical. So when you're doing RAG and you're doing vector on these things, how can you bring back some of that, and then maybe also like personalization. Like, have you had many conversations with this user before? If it's an employee at your company, do we know about their role, their job, why they might be talking to this agent? Like, how's it going to help them with their work? Or if it's a customer that's external, what activity have we had with them? What's maybe their order history or their relationship? And thinking about bringing all of that information in, it can be overwhelming. And part of it is about I say the right information. You think about the techniques there, it's about not necessarily having too large of a prompt. When you think about context windows and these kinds of things, it's not even about cost, or really even performance, although those things obviously have implications to this. It's about consistency and accuracy of the behavior of what you like to get from the LLM. And so understanding the techniques of what information to pull back in, how to order it, and kind of do that, this changes the outcome. Now, as an agent, the difference between a prompt, like a one-shot prompt, and an agent is effectively doing this in a kind of a dynamic looping pattern, right? So the agent would look at information, and then it might, for example, make a choice to go to either, let's say, respond in a conversation, or to go deeper and maybe look for some more information, do some, we'll call it research for a second, if you're thinking of it that way. Go find some more information before it responds. And then depending on what it comes up with next, it might decide, well, I got the information that the customer asked for, the user asked for, I'm going to respond with it. Or maybe what it found on behalf of that user is actually information that led to more questions for it, that it didn't have the answer yet. So now, and I'll give you an example, just to make this concrete. A very canonical example, since we've all been there with e-commerce, hey, I order a product and it hasn't shown up yet, and I might need to say, hey, what's going on? This product is, this is my order. Where is my order? Is the classic thing. It's 2 days late, and I'm order number 1, 2, 3, 4, and just that kind of an utterance. Maybe the agent goes and looks up the order 1, 2, 3, 4, pulls it back, and depending on the answer, what it got back, maybe the order is delivered. And then it might say, well, it's delivered. Maybe, have you checked your porch? Is it there? Is it stolen? Maybe I should look up my policies on lost and stolen packages before I respond. Or maybe when it pulled back that order, that same 1, 2, 3, 4 order, it would learn that it's in transit. And it would decide that it needs to go check the carriers to see actually what's going on, if it's held up and when the actual arrival date is. Or maybe it checked 1, 2, 3, 4 and found that there was actually no order 1, 2, 3, 4. And maybe the user was confused. And it responded right away and said, hey, are you sure this is the right order number? And that level of agency is effectively being able to loop on information. So everything about selecting the right data into the prompt, thinking about all those different contexts coming together, and then the orchestration on top of that. Because if it's looping multiple times and it's seeking information, we will let it do that maybe a half dozen times or more. I mean, there's safeguards for this kind of thing. But as it's doing research, you're asking that same question of what data, what information, how are you interfacing to this large language model dynamically sub-second each time it's changing? Does that make sense?
Yeah. I'm still following. A lot of questions came up with doing your story, because I wonder now, you're using small steps with the AI to process a request, because it can do many things. It has to check out a lot of things, and all these small steps are being controlled by your overlaying, I think it's called Atlas processing.
Reasoning engine?
Engine, sorry. But that's not an LLM. That's a different kind of AI that you're using for those steps, right?
Yep.
Yeah.
So an LLM is a pre-trained model, right?
Yeah.
Okay. So GPT, generally pre-trained models, so lots of information, and you get these emergent breakthrough behaviors. It's awesome. It's amazing. Yeah. We've all seen it. There isn't a single model. I mean, we look at this as the models are changing rapidly, yes. So fast. I mean, there's new models every day, but the big models, every few months.
Yeah, every 3 months or so.
Yeah, that's right. And we've seen this incredible catch up from open weight models, open source models. I mean, I would not have predicted that we were going to be at this stage we're at right now, and how relatively low cost it is.
I think nobody did.
All right, and so there's all this uncertainty about these models, and so. And our customers are, we have, if you're listening to this, you have large customers, you have moving large organizations, making a purchasing and implementation decision, rolling out new product and features to your customers, is a lot of work, to move down a path. And the idea that the rug that you're building on the foundation that you're right, is going to get pulled out from underneath you or change so much, this is a really hard thing to do. And given that we're at this moment where it's moving so quickly, we've made choices to stay effectively agnostic or above that. Yeah. So you can actually swap out models that you want to have for that reasoning engine or reasoning planning.
Yeah, because that's what I found interesting. At one point, Mark says, just using an LLM and do trial and error, you're not going to get the results you want, because it won't be as good, and it can go off. It can go its own way, and you need to have an AI that has an expected outcome, that it's not going to hallucinate or do strange things.
Yep.
So you need to do it in a controlled environment, but you're still using those same LLMs, but in a controlled way to get the output.
That's right. So some of the techniques I mentioned about choosing what data goes into a prompt inside of this inner agentic loop, inside this reasoning engine, right? So this is happening multiple times. Inside of that, there's also deterministic logic, that you can have policies that as the thinking or state of that loop, as the agent is moving through its research or through the conversation, as new information becomes available. I'll give you a really simple and canonical example would be authentication. Yeah. If I'm having a conversation with an authenticated user versus a non-authenticated user, what's the difference in terms of what the LLM can do? And it turns out it's important to make it's a distinct difference, right? So certain what we would call topics and instructions. And topics to us is a construct of being able to describe a focus of the agent at a given moment in time. So you could say, if you're doing things like the example I was given about the order management, that would be a topic where it's focusing on understanding how to help customers with orders or order management. And if it was an unauthenticated session, a conversation, then it may only have the ability to do things like look up information of an order if it has both an order ID and an email address and maybe something else, or it could authenticate the session and suddenly have more actions and availability to it. So this eliminates this like boundary of hallucination for its ability to actually have effect, to take action.
But did you build different object models within the Atlas reasoning engine to process order management or to do pricing engine, or your different AIs that you train to do that? How does it work?
There are high level LLMs that are brought in for basically like this reasoning and planning, right? Like you think of that, and there's very few models that we assess all the models for this. We put a benchmark out, by the way. We call it our CRM benchmark, where we look at all these foundational models. There are only, really it's been GPT-4, but there's now other models that have, and this is part of the excitement of things that are changing so fast, that are now getting to the point where we would feel that we would, from our assessment, say to our customers that this is now good for this highest level reasoning and planning. There are lots of use cases that do not require that level of, I'll say intelligence or cognitive ability of the reasoning and planning. Like summarization is pretty classic. Summarization is pretty classic. Additionally, there are built from scratch models inside of the reasoning engine. By the way, there are models that are running all the time for safeguards and kind of guardrails. You can imagine you almost have almost like a supervisor that's running in the background, looking at what the agent is doing, to be able to stop things or keep it on rails or within boundaries. We have models that look at toxicity. We have models that look at prompt defense. So imagine there's a whole bunch of smaller specific models.
Domain models.
That's right, and it's not domain from the perspective of necessarily industry yet, although that is definitely of an interest, and we're looking through those things. But it's really about having models that would apply to all kinds of things that pretty much every business would want to have. Like, is somebody trying to be malicious, like a prompt defense or something to that effect? And then we're using the highest level, more kind of cognitive models to kind of draw a box around them, a boundary of guardrails of what they can and cannot do, and using them to kind of reason through information. And those models you can swap out as more models of these larger kind of frontier models. As that landscape continues to evolve, our customers aren't going to be locked in.
Yeah, it's a very advanced piece of technology, I guess, because you're using so many different models within the reasoning engine.
And the way that this is done is that you don't have to know that. Like, you don't need to have a computer science degree. You don't need to completely understand it. And what we're doing is shipping a product with this is basically our commitment to continue to improve things as the technology changes, and do it in a way that's backwards compatible, right? Yeah. So that you don't have to know. It just kind of keeps getting SaaS, right? It just gets better. It's in the cloud.
Okay. And the data cloud is basically the foundation of what makes your AI so good, right? Because the data cloud is the centerpiece where you get all the data from.
Data cloud is the center of all of the information that's coming from, that's data. It's in the name, data cloud. So is the AI needs to be able to look up information and kind of reason across things. That it needs data to do that. It's coming from data cloud. It could also, by the way, come from external systems as well.
Because how do you make sure the external data sources are also summarized in a way that the AI can handle it? Because you can also throw too much data at it, like you said in the beginning of this episode.
That's right.
You need to manage that as well, right?
So that's actually a great point that you're hitting on. You can have the agents take action. An action can be pretty much anything you want. An action can be look something up from another system, right? So it can be, and that is a way to connect data effectively. It's an API kind of aspect of a RAG kind of mentality, right? If you want to filter that information down, you say it's too much. Like, for example, I'm doing a search across, let's call it, actually we have a customer, Easy Cater, has a lot of information on hundreds of thousands of catering restaurants, and they all have menus and what they build. It's a lot of unstructured data. And one way to do it would be hit an API for an action to just search for caterers in an area or some kind of parametric search. Another way to do it would be load that unstructured data into Data Cloud. And what the benefit of that is that, and this is some of the techniques that we've heard from our customers perform, what they've reported internally back to us is over twice as accurate in terms of the answers we give versus the other techniques on the same data, the same questions. Okay, and these techniques are all, when you put data in Data Cloud, these techniques kick on automatically. So if you want to be able to filter data more accurately, your own unstructured data, if you move it into Data Cloud, you can connect an agent to that data so that it knows how to articulate questions better, it knows how to reason and reflect on what those responses, if they're accurate, and that ultimately gets more accurate data back into that prompt, and ultimately, like we say, like, the AI, if you give it bad data, you're going to get a bad outcome.
Yeah, okay. You are expecting thousands of agents, so it will stress your database as well. Are you confident that the infrastructure is up to the task? Because we see other vendors in your area replacing their databases with others, or adding NoSQL databases, or adding Elasticsearch. I've seen many different evolvements in that.
I mean, you're asking a great question. 1,000 is not the problem. It's going to be billions. But the point is there a limit for scale?
Yeah, is there a limit for scale? Yeah, that's
one of the most amazing things. I'm a tech geek kind of guy. Yeah. One of the most amazing things about vector search, embeddings, and how this works is it is all it's meaning and search with semantics, but it all boils basically down to math. And it turns out that computers, GPUs, and kind of inverted indexes on databases, when you're searching through numbers, like, are really scalable when it comes to math. Okay. So with vector, it's actually more scalable in many ways than other database indexes that we've had for many years. So the answer is not really worried about that scale. And also, by the way, everything that we do in our infrastructure, and this is part of the whole cloud, is that it auto scales for us. We are monitoring this. This is what our job is for our customers. Yeah. Maintain uptime, scale from. They shouldn't have to think about any of these things, right?
That's true, but I see other vendors just replacing the whole database infrastructure because it's not good enough. So that's why I asked, because when you created Data Cloud, you weren't thinking about this use case back in the day.
Yeah, Data Cloud is designed for immense scale. Okay. I think that the agents are going to, honestly, it's querying data more as it's needed, more surgically. Okay. I would imagine that other systems will be stressed more from agents than Data Cloud.
Okay, final question. You're doing a world tour. You're going to many countries to present this and help customers build their agents. I saw you coming to many European countries with different languages.
Yes.
Is that a problem? Because you need to support German, Dutch, French, Spanish, I don't know what else there is.
So right now, in October, when we have general availability of this, we will support French, Italian, German, Spanish, Japanese, and Portuguese.
Okay.
And
that's a lot.
Yeah, that's good. It represents a large set. Yeah. Now, we know there's a lot of languages that I didn't mention right there. We have 40 total languages that Salesforce supports kind of across the product lines. That's the full set. That's our target. So our plan is, in our spring release, which is February, to offer support for all 40 of those with this. Now, also, large language models are able to speak many languages. Okay, some better than others, and they're getting better all the time. This is also why you want that agility in which language model you have, and the sort of back end. When we say that a language is supported or not, it's more of from a formal perspective, documentation, things are like, there's a lot more kind of behind that versus even right now, like I've seen, we don't technically support Japanese until it, but I've seen it work from our Japanese friends more. So it's there. It'll get better every day. And by the way, another question that's related to language is also data residency and privacy and these kinds of things about where it runs. And so that's another exciting thing as we move into models that are able to reasoning and planning, these frontier models that are able to be more on the kind of open source side, where you can run them more into a private, private cloud. Exactly. And so this allows us to move the compute, move the GPUs, move the models, inference time, closer to where the data lives, abiding by local regulations and stuff. So this is also something that I can't give exact dates on that, but I will say that in the last handful of months, few months, we have seen things that are now looking really positive for being able to that we're getting ready to roll out and kind of expand to that, which will unlock this for many of our international customers.
Yeah, in Europe that's very important, as well as some Middle Eastern countries as well, that they want the data residency to be
That's
there.
right, and also regulated industries that are, it doesn't really matter if you're in geography too as well. So all things trending that way, language, data residency, privacy, things are looking good. We're having more models that are all competing with each other that are at that level, and we're just kind of trying to make this all productized, so our customers don't have to go hire an army of computer science and PhD people to build this out. They don't have to relearn all the lessons that we've done, and we can build software for them to just make ultimately everybody go faster and drive customer success.
And the smaller models in the reasoning engine are not language dependent then, on English.
No.
Okay, so that's good. Okay, thank you, Adam. I see you have to go, so you're a busy man. So thank you for the conversation.
Thank you very much.
And hopefully we talk again in the future.
Absolutely.
Okay, thanks.
Thanks so much for tuning in to this episode of Techzine Talks on Tour. If you're enjoying the show, please feel free to rate, subscribe, and leave a review wherever you listen to your podcasts. That helps others find the show, and we greatly appreciate it. If you'd like more information, please feel free to visit techzine.eu, where we cover everything, everywhere. Thanks again for listening, and we hope you'll join us again on the next episode of Techzine Talks on Tour.